A new interstellar visitor has suddenly appeared in our skies, and it is rewriting the script. On September 12, 2025, instruments detected an object so immense and luminous that astronomers immediately realized they were watching something extraordinary. It's roughly 100 times brighter and far larger than the metallic probe known as 3I/Atlas, and, most alarmingly, it is headed straight toward the Sun. The first detection came from SWAN, an instrument aboard the SOHO spacecraft designed to monitor the solar wind. 2 days later, Australian comet expert Michael Matiaso captured a photograph that stunned the scientific community. A tail that stretches 2.5 degrees across the sky, approximately 5 full moons in width, dwarfing the thin plume that trails 3I/Atlas. The International Astronomical Union has now given it a formal designation, C/2025 R2 Swan, after its initial tag, Swan 25b. The announcement landed like a thunderclap across observatories worldwide. If this sounds like the setup to science fiction, that reaction is natural. The simultaneous appearance of Swan R2 and 3I/Atlas raises questions that verge on the uncanny. Why would two anomalous interstellar objects converge on the inner solar system almost at the same time? Are we witnessing a natural fragmentation event, a random alignment, or something far more deliberate? Early on, Avi Lobo and his colleagues considered straightforward possibilities. Could Swan be a fragment of 3I/Atlas, debris torn from a larger body, or perhaps a probe deployed by a parent craft? Trajectory reconstructions, however, quickly ruled out that tidy explanation. Senior collaborator Peter Vess showed that the two objects arrived from entirely different directions of the sky. Swan came in from the region near Aquarius, while 3I/Atlas approached from Sagittarius, close to the plane of the Milky Way. Different origins, different vectors, yet both paths are bending toward nearly identical solar encounter points. The timing intensifies the mystery. Both bodies will swing close to the Sun in October 2025, nearly side by side on the scale of inner system dynamics. At perihelion, Swan will come within roughly 150 million kilometers of the Sun. 3I/Atlas will pass at about 203 million kilometers. That 50 million kilometer separation is trivial astronomically, and is liable to shrink as gravitational interactions and non-gravitational accelerations alter their courses. Even more unnerving, after perihelion, both objects will vanish behind the Sun's glare, out of sight from ground-based observatories. Two interstellar visitors, overlapping approach windows, one solar encounter, and no way to watch what happens during that crucial close pass. When you compare the two craft, the contrast is stark. 3I/Atlas already shook assumptions. Spectroscopic studies of Atlas revealed a body dominated by nickel with a surprising absence of iron, a metallurgical fingerprint that reads more like manufacture than natural formation. Instruments measured a compact reactor inside Atlas producing about 10 gigawatts of continuous power, comparable to the output of a large civilian power plant, and Atlas's tail behaved unlike any cometary coma recorded in modern astronomy. Its emissions were tightly collimated, resembling exhaust from a propulsion system more than sublimating ice. As Atlas neared the Sun, researchers documented abrupt color shifts and thrust-like behavior suggesting controlled burn adjustments as it heated, what Lobo calls thrust mix modulation. If Atlas read like a reconnaissance vessel, Swan R2 reads like an armored mothership. Lobo's team detected a vast silver plasma envelope wrapped around a broad nickel-cobalt hull that dwarfs Atlas's frame. This envelope isn't passive. It operates like a dynamic electromagnetic barrier, bending the solar wind and deflecting charged particles in ways a solid shell cannot. Swan's tail spans roughly 2 degrees of sky, about 5 lunar diameters, making it nearly 100 times larger in apparent extent than Atlas's narrow plume. As Swan approaches perihelion, its glow flares and shifts spectral character, and high-resolution monitoring picked up tiny, precise thrust pulses, the signature of a directed plasma drive steering system. The exhaust composition is a dense nickel-cobalt plasma mixed with carbon monoxide and carbon dioxide. A mixture, Lobo argues, is impossible to produce naturally without engineered directed plasma propulsion. The power figures move us from awe to alarm. Atlas's 10-gigawatt core was already extraordinary, but Swan's energy output dwarfs that. Lobo's preliminary analyses estimate Swan's plasma core releasing energy in the order of tens of terawatts, more than 10,000 gigawatts of sustained output. He compares that power density to a scaled, contained equivalent of colliding compact objects, the kind of energetic event normally associated with catastrophic astrophysical phenomena, harnessed and focused within a single machine. In Lobo's words, Atlas was a scout. Swan R2 is a fortress. Orbit determinations from NASA and JPL add another deeply disquieting layer. While 3I/Atlas appears to be on a hyperbolic flyby, a one-time visitor, Swan R2 fits a closed, extremely long-period orbit with a return interval of roughly 22,554 years. That means Swan is not a single ephemeral visitor. It is a recurring presence on a timescale that dwarfs recorded human history. For a civilization capable of designing machines with relativistic cruise profiles or long-term time-dilated missions, a 22,000-year patrol could be routine. What seems unthinkably rare to us might be ordinary operations for an advanced actor. That orbital insight reshapes interpretation. If Swan R2 is engineered and returns on a fixed schedule, each passage could perform practical functions, harvesting superheated solar plasma as fuel, calibrating, servicing, or downloading data from an extensive sensor network hidden across the planets, asteroids, or even beneath polar ice, checking on a fleet of dormant or parked devices, or updating navigation beacons and star charts. The sun could serve both as a power source and a timing beacon. A 22,000-year loop gives ample time for distant operations to unfold and for updated information to accumulate between visits. To an operator on near-light-speed trajectories, time dilation could compress the subjective interval, turning millennia into months or years for the travelers. A darker operational hypothesis is that Swan R2 has come to interact with 3I/Atlas itself. If Atlas was a reconnaissance probe, Swan could be the retrieval or heavy service vessel, arriving to collect Atlas's data, remove its reactor core, or neutralize it before humans can intervene. Some teams speculate the two craft may represent opposing factions, rival probe classes converging to control whatever resource the Sun's environment provides. To these builders, the Sun's magnetic topology and gravitational well could be critical infrastructure for powering or stabilizing interstellar links, wormhole anchors, or galactic relay networks. What appears to us as sunlight might be, to them, fuel and infrastructure. This technical debate bleeds into provocative archaeological speculation. Graham Hancock and others point out that Swan R2's roughly 22,000-year period coincides with an era at the end of the last ice age when human societies abruptly began erecting monumental structures, aligning architecture with the heavens and recording precise astronomical knowledge. Hancock argues that ancient builders may have encoded awareness of recurring stellar visitors into their monuments. The Great Pyramid's shafts aligned with stellar coordinates, megalithic complexes oriented to predictable celestial paths. In his view, those architectural choices could be echoes of an earlier encounter. A civilization watching a large visitor blaze across the sky with a five-moon tail, building monuments to mark or warn of its return. Lobo is cautious about conflating pattern with proof, but he acknowledges the coincidence and presses a different question. Why now? After apparent millennia of quiet, astronomers have observed 3 anomalous visitors in less than a decade. OMUAMUA in 2017, the metallic 3I/Atlas more recently, and now Swan R2. Lobo offers a sobering explanation rooted in recent human behavior. For the last century, we've been broadcasting our existence more broadly than any prior species. Radio and television leakage, planetary radar, deliberate messages like the Arecibo transmission, and cultural artifacts like the Voyager Golden Records. That expanding bubble of technosignatures is now intersecting more star systems. Under Lobo's scenario, our broadcast didn't summon a single probe but may have reactivated an ancient monitoring protocol. An automated sentinel architecture deployed eons ago to watch for emergent technological civilizations, might be programmed to escalate its response once a detectability threshold is crossed. The observed sequence, stealthy scout, active reconnaissance unit with a reactor, then a heavy response plasma fortress, could be a procedural cascade. Examine, evaluate, and, if necessary, retrieve or intervene. Where we see hopeful outreach like the Golden Record as a benign greeting, an ancient guardian network might interpret it as a marker that triggers audit and enforcement routines. Complicating all of this is the public posture of official institutions. Governments and major space agencies have been remarkably restrained in their public statements. There have been no global emergency briefings or sweeping multinational disclosures so far. Statements have been measured, technical, and minimal. That silence fuels speculation about preparedness, the political calculus of disclosure, and the responsibilities of institutions when confronted with phenomena that could challenge worldviews and geopolitical stability. The quieter the official voice, the louder conspiracy grows in the public square. Scientific skepticism demands we keep alternate explanations on the table. It remains possible that Swan R2 and 3I/Atlas are exotic natural objects exhibiting uncommon materials or unusual interactions with the solar environment that mimic engineered signatures. New mineralogies, uncommon plasma chemistry under intense solar flux, or rare dynamical effects could present as engineered behavior unless we gather more and better data. The scientific method requires patient observation and rigorous hypothesis testing, but the convergence of anomalous materials, controlled seeming propulsion signatures, overpowering energy outputs, and the coincident timing of two massive visitors cannot be dismissed casually. So, where does this leave us? Could these be routine service runs for an ancient interstellar system? Evidence of an ancient surveillance network following a long schedule? Or a direct response to humanity's growing techno-signature footprint? All remain plausible to varying degrees. The one certainty is that our observational net, powerful as it is, still has gaps. Two sprawling objects can approach, swing by the sun, and slip behind the star before we fully understand their purpose. Which of these possibilities do you find most convincing? Scheduled maintenance, surveillance, or a response to our signals? Drop your thoughts in the comments. If you want ongoing breakdowns as this story evolves, hit like and subscribe. We'll keep watching the skies together and ask the hard questions as new data arrives.